Greetings of the day, dear students. Now in this video we are going to discuss about the uh, power factor and we will see in this video in a step-by-step manner some examples. Already we have completed the, before watching this video please watch real power, right, and complex power concept. After completing the power concept please watch the power factor, right. Now, and we will also see some examples how to find out the power factor. Observe, uh, it is simply defined as the cosine of the phase difference between voltage and current. Simple. Cosine. Cosine of the angle between voltage and current is called the power factor. And also it is also the cosine of angle of load impedance. We will tell you, I will explain you what does it mean. For example, in the previous topics already we have seen what about complex power or apparent power S equal to V. I understood these two values are RMS values, VRMS into IRMS. What about S represents which power? Apparent power, right? And the real power P equal to VI cos theta, angle between voltage and current. And the reactive power Q VI sin theta. Apparent power expressed in volt ampere units are, and this one in watts, and this one reactive power in units are volt ampere reactive. Up to here we have completed in the previous discussion, right? Now if you take simply the product of capital P divided by S, what will happen? VI cos theta by VI get cancelled. Simply you will get cos of theta V minus theta I. You will get the cosine of the angle between voltage and current. That is defined as the power factor. Now it's a ratio of which two powers? Real power and apparent power. Real power and apparent power. Right? Now let me do the small problem. For example, P equal to 80 watt and S equal to 100 volt ampere. Then what is the power factor? From the definition, capital P divided by capital S. P equal to 80 divided by 100. Now you will get 0.8. 0.8 is the power factor. Very simple. Right? Now one more example. In this diagram, you observe he gave you the voltage phasor and this V is some V at an angle 0 and this I is at an angle 36.86 degrees. What is the other definition? Cosine of angle between voltage and current. So cos of, you don't bother whether it is plus 36 or minus 36. Cos of minus theta is also same as cos theta. But the important thing is, depending upon whether it is minus theta or plus theta, you can say whether it is lagging or leading. Lagging or leading. That one we can decide, right? Yeah. Now you got the angle 36.86. Cos of 36.86 is 0.8. So the power factor is how much? 0.8. Clear? Yeah. Now from impedance also we can tell. Impedance, do you remember? Z equal to R plus Jx. What about mod Z? Mod Z is root over R square plus X square. What about theta? Tan inverse of X by R. Now this angle theta represents the power factor. Very simple. If you note, if your impedance is given 2 plus J3, what will be the power factor? Very simple. Theta equal to tan inverse of x by r. You just immediately recollect its general form. Z equal to r plus jx. R plus jx. So theta equal to tan inverse of 3 by 2. Now this is angle theta. What is the power factor? Cos of theta is your power factor. Very simple. 2 plus J3. Right? Now let me see one more example. Observe, for this phasor, what is the power factor? Very important. Is there any angle difference between the voltage and current? Both are in phase. Both are in phase. So what is the angle between them is 0. We will get such kind of case when if you are having a resistor, if some voltage is applied, okay, and positive negative some 12 volts, if some current I is flowing in the resistor, in that case if voltage waveform is like this and the current also will be on the same axis. In a resistor, voltage and current will be in phase. There won't be any angle difference. Clear? If there is no angle difference, what is cos 0? 1. Unity. This is the maximum value we can get. So what is the maximum value of power factor? Unity. 1. What could be the minimum value? Cos 90, 0. So it varies between 0 to 1. The power factor value maximum you can expect. You can't say somewhere power factor equal to 1.5, meaningless. Under any circumstances you won't get 1.5. The maximum it can reach is 1. Okay, good. Now power factor cos 0 is 1, unity. Clear? Observe here, in this case voltage is like this, current is like this. What is the angle difference? 90 degrees. Do you recollect in the DC circuits, RLC circuit elements basics, while discussing that for which element you can get a graph like this, for which element the angle between current and voltage will be 90 degrees? Inductor or capacitor? For both the things. Another point you have to observe is this current is leading the voltage by how much angle? 90 degrees. Then obviously this will be the case for a capacitor. This will be the case for a capacitor. If you are having a voltage like this, if current is flowing in the capacitor, the angle difference between voltage and current will be 90 degrees. Pure capacitor. Then what will be the power factor? Cos 90, 0. For example, if the voltage is like this and if the current is like this given, here also 90 degrees only. But what is the difference? Here also I. In this context, I lags V. This will be the case when if it is inductor. For inductor, if you have applied some voltage, if some current I is flowing, right? Now this will be the case. The angle between voltage and current will be 90 degrees. I lags V. Pure inductor. By how much angle? 90 degrees. Then also power factor will be cos 90. 0 only. Clear? Yeah. Now power factor maximum value is unity. This is trigonometric basic. Cos of theta equals to cos of minus theta. Its meaning is whether it is cos 30 degrees is same as cos of minus 30 degrees. Both you will get the same answer. Minimum value is 0. Looking at this diagram itself, immediately you should say I is leading voltage. Under which case? Capacitive. Under capacitive. For capacitors you will get such kind of phasor diagram. Very important. Capacitive load. Current leads voltage in capacitor. I is rotated in which direction? Anti-clockwise. Here I is rotated in which direction? Clockwise. But in this direction what is the angle? Minus 30 degrees. Both the things you will get 0.866 only. But the thing is, you should use the word 0.866 lead. Lead, L-E-A-D, lead. Power factor is leading. Here also 0.866 only. But here cos of minus 30. You should use the word lagging. Lagging. 0.866 lag. Enough. Inductor lagging. Capacitor leading. Pure resistor in phase. Voltage and current will be in phase. Power factor is inductive load. Here you are having not exactly 90 degrees. Some 30 degrees is there. Its meaning is along with inductor some resistive element is also there. Some RL combination, something like this. Here exactly 90 degrees you not got. Its meaning is something along with capacitor. Okay, some resistor is also there, like that. It is the meaning, right? So these are the different examples. But whatever might be the case, power factor, please keep in mind cosine of the angle between voltage and current is the power factor. In terms of power, if you want to do it, simply capital P, very very important. Power factor cos phi denoted with cos phi. Cos phi equal to P divided by S. This formula is very very important. Okay, yeah. So with this, we will stop this topic. Thank you.